Alright, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump into it here. We're trying to figure out if this series converges or if it diverges. So I actually use a combination of tests if I'm just going to get a quick snapshot of whether I think it's going to converge or diverge. If you kind of take a bunch of different tests and you kind of smash them into one, it's not official, it's not by the book, but essentially, like if you combine p series and exponential and ratio and root into one test, limit comparison test, direct comparison test, you smash them all kind of into one test. You can essentially kind of just look at it and tell if it's going to converge or not in most cases. And that would be if the degree equivalence, so the degree or something very close to the degree, is more than one greater in the denominator than it is in the numerator. So for this is actually very, very close to just being a straight up p-series. And if we want to do this by the book here, then we're going to use p-series and then either limit comparison or direct comparison test. I usually opt for limit comparison. It's less confusing about the rules for it. Direct comparison, you have to be a little more careful. With limit comparison, you just take the limit and then it works. So I usually prefer to do limit comparison test. This is going to converge. I know that for a fact. The denominator power is 3, and the numerator has a power of 0. So the denominator is more than 1 greater in degree than the numerator. This is definitely going to converge. But as far as doing it by the book here, we're going to use a couple different tests. So let me change. I like to use green, blue, and yellow usually. Some of my favorite colors. Let's start with creating a different series. When you're creating a different series, a simpler one, the simplest thing to do, and you can't always get away with doing it this way, but basically if you want to create a simpler one, the simple version is basically you take out, I'll say take out, I guess. Take out anything that's being added, subtracted, multiplied, or divided. If you take out anything that's being added, subtracted, multiplied, or divided, you've basically got yourself a simpler series. Think like parent function of a polynomial, or in any function really. But a parent function, that's what you're doing, is you're taking out anything that's being added, subtracted, multiplied, or divided. So if I take out the plus 8, I would end up with a series of 1 over n cubed. Okay, so this is going to be my b series. This is my b sub n. Okay, all I did was take out the n plus 8 part of it, the plus 8 part of it. So the 1 over n cubed plus 8 is going to be the a sub n. So all of this is a sub n. Okie doke. So one of them is bigger than the other. It's a little easier to tell on this one. If you get rid of the plus 8, then the denominator will be smaller, which makes the number bigger. If the denominator is bigger, the number is smaller, and vice versa. So the b sub n is actually going to be greater than the other. So we only need to know that for if you're going to use direct comparison test. Limit comparison test, they just need to both be, one of them can have 0 values, but they both need to be positive, more or less. And we're starting at n equals 1. I kind of covered it up a little bit there. But n is equal to 1 is where we're starting. So if I plug in 1 for either of these series, and then I keep plugging in higher and higher numbers, going to infinity, I'm going to always have a positive number. So we're good. And because neither of them have any 0 values, it actually doesn't really matter which one I call A and which one I call B. If one of them had a 0 value, I'd have to have that one be called A, but it actually doesn't matter. So the reason why that's important to note is that I could switch the names of them because neither of them have 0 values, is that I have some options here. So when I actually go to do my tests, I'm going to have to do a limit test. Essentially, I'm doing a limit as n goes to infinity. And the rule is to do a over b. But because I can change their names, one of them can be a and the other one can be b, or I can vice versa. I'll just do whichever one I like better. And I think I would like to do 1 over n cubed over 1 over n cubed plus 8. I really don't think it's going to actually matter. So this needs to be a positive constant in order for this to work. Well, this is going to be the same thing as the limit as n goes to infinity, and then I would keep change flip. So I'd keep it as 1 over n cubed, change from divide to times, and then flip it so that the n cubed plus 8 is in the numerator actually. So it actually will end up being the n cubed plus 8 in the numerator and the n cubed in the denominator. So this is just a rational function, and according to rational function rules, if you have the degree in the numerator is the same as in the denominator, then the horizontal asymptote on both sides, it's not just a one-sided horizontal like for an exponential function, but the both-sided horizontal asymptote of a rational function in this scenario where the degrees are the same in the numerator and the denominator is just going to be equal to the division or the quotient of the leading coefficients. So this is going to equal 1. Well, 1 is greater than 0 and it's less than infinity. It has to be a positive constant in order for the limit test to work. So now the limit test I should say the limit comparison test works. Because another word for the limit test is the convergence test or the nth term test. You guys might call it one of those. So I got to differentiate between those because it's also sometimes called the limit test. This is the limit comparison test that I'm doing right now. So because it's successful, that means that if A converges, B converges. If B converges, A converges. Also, if A diverges, then B diverges. And if B diverges, then A diverges. So that's a strong test. The limit comparison test is a stronger test because it gives you more options. With the direct comparison test, it's only like if the stronger, let's say B is the stronger function, if the stronger function converges, then the weaker function does. And if the weaker function diverges, then the stronger one diverges. It's only those two. You don't have 4 different options like I just mentioned earlier. So limit test, I think, my opinion, it's just a better test. Okay, so their fates are tied, essentially. And then what we want to do now that we know that the limit test works is that we just use p-series test. Well, the b sub n converges because of p-series, right? So this is a p-value of 3. So according to the p-series test, so I'm going to start writing this over here since we're pretty much at our answer now. So we would say that the series with b sub n in it converges. Okay, converges by the p-series test. By the p-series. Can you guys see that? Yeah. By the p-series test. I'm going to have to write the rest of it down over here. Okay, so b sub n converges by the p-series test, and then therefore, and there's actually a symbol for therefore in math, but I'm not gonna be too fancy other than writing in cursive. I just write in cursive a lot because of the pen stroke thing. Less pen strokes means less lag. So by the p-series test, therefore a sub n, and actually let's do this proper here. We're trying to do this by the book because we actually already got the answer before we even really dove into this here. But we're trying to be by the book. That way your professor can't mark you off on this, okay? So n equals 1 to infinity of a sub n. All right, so b sub n converges by the p-series test. Therefore, a sub n converges by the limit comparison test. I'm going to squeeze this in so I don't have to try to scroll on here. By the limit comparison test. Aha! It does fit, just barely. Okay. So that's it. That's like the by the book answer. But like I was saying before, if you just look at the degree in the denominator and the degree in the numerator, Even if there's other degrees, it's the highest one, right? The highest one makes up the degree. So even for more complicated ones, which we'll look at a couple of those in the weeks to come here, I'll probably make a whole series on convergence, a whole pun not intended, I guess, a whole series on series, a series. I'll I'll come up with a better title, I'm sure. But this is probably the first to come in a few of these because series is one of the harder topics. It's towards the end of Calc 2, so definitely something to look at. And hey, if you want to look at a Calc 2 course, speaking of just a whole thing on Calc 2, I have one of those on my website. You can go check it out, myersmathematics.com. As well as a PDF called The 5 Math Mistakes Everyone Makes and How to Avoid Them. You can check that out as well. Or, of course, look at other videos that are going to be in a playlist that should be popping up somewhere around here as the video comes to a close. So, I hope that's been helpful, and I'll catch you guys in the next video. Blessings, y'all.